welcome back to Serah's computer sessions. So today, this class is the last class on data types. Even though I'm saying that it's the last class, it's not actually because I will be, sharing extra knowledge on data types later in the late future when I will be dealing with other subjects, other topics that have relation with data types. Okay, even when we are doing programs we will be exploring more about data types. So without much delay, let's go and see what I have for you today. I had closed my last session with this slide in which I have depicted the different categories of basic data types. So today in this class, I will be teaching the different sizes as well as the range of values that are assigned or that are given for these basic data types, as well as modifiers that can be used along with the data types. Okay, so before starting, let me tell you once again, those who have not watched my previous two videos on data types, please watch that and come to this video, because I've given a detailed explanation of how actually the values are being calculated, and those explanations are simple also. Okay, those who know about all those things can directly watch this video. Another thing that I have to clarify is, see, I truly aim at those students who are going to school, as well as those beginners who are just at the starting phase of study in computer science. So because I consider them also, I always try to make my classes as simple as possible. So when I do that, certain concepts have to be taken in a different perspective. For example, these data types, when we actually teach the data types and the range of values, we use a clock diagram rather than a number line. Because the clock diagram is that which clearly explains how the calculation goes. But then drawing a clock diagram and teaching that without teaching what a modular arithmetic is and what are the different basic encoding techniques and all, it will be difficult for you people to understand. So that's the reason why I have chosen number line to teach data types, because it is simple. Okay, so maybe later on when circumstances are favorable, I will be taking classes on the different basic encoding techniques, as well as how can we actually move along with the study of data types with the clock diagram, etc. Okay, so I hope you people are with me and you understand what I actually have conveyed you. So let's start with today's class. Okay, we'll move on to the void at first, because it's easy to understand. Void data type, the size allocated, as well as the range of values. Okay, so yes, void. What did I tell you about void data type in my last video? Yes, I told that void means it's empty. Wherever we have to use our data, but if the data is empty, we can specify void. It usually comes along with functions and pointer. I've not taken functions and pointers. I haven't even mentioned about them in my previous video, so I don't want to make it complex now. But please try to understand that it's used with functions. When we use functions in programming, there will be circumstances where we have to return a value back to the main function and all. So when we have to return an empty value, or when we are not returning anything, we usually use void. Okay, this will be dealt by myself in my future sessions where I'll take functions in detail, don't worry. So we'll look into the size allocated for void. Whether it is a 16-bit machine or a 32-bit machine, the size allocated is 8 and the range is valueless because it doesn't store any value. Okay, but a minimum amount of size should be allocated as it is a data type. Okay, so next we'll move on to the char data type, and that too for a 16-bit computer. The size allocated for a char data type for a 16-bit computer is 8 bits. Okay, now see the table. You can see that there are two keywords that are included in the second column, and that is the column of the range, and they are signed as well as unsigned. From there, I've written in brackets that unsigned is to consider only positive values and signed is to consider both positive and negative values. Those who have watched my last video or the last class where I had actually taught you how to calculate the range, we have seen both, right? Only positive case as well as when we consider both positive and negative case. So there are actually two cases while we take the char data type. So let's see how the range differs when we use unsigned and signed. Okay, for an unsigned character, if the n is 8, what is the next step? 8 bits in memory can actually generate 2 raised to 8 values. The value of 2 raised to 8 is 256. You have to know the power values of 2 when you're studying these data types. Okay, so out of the 256 values, only one value can be held in that particular memory at a time. So the minimum value will be, yeah, obviously it will be 0 because we are considering unsigned character where only positive values are taken. Okay, don't confuse yourself by thinking how can a character take a numerical value. Whenever you enter a character, its corresponding ASCII value is being inserted into the memory, or the corresponding binary representation of the ASCII value. Okay, so that is the reason why we take positive and negative values and stuffs like that in character data type. Anyway, just leave it. The minimum value for an unsigned character will be 0 and the maximum value will be 255. Those who have watched my last video will understand this better because there I had actually explained using a number line. Okay, so you know, when we take 256 numbers and that too starting from 0, the last number will be obviously 255. So how do you get that with an equation? You get it 250, you get the value 255 by taking 2 raised to 8 minus 1. Okay, so the range for an unsigned character, and that too for a 16-bit computer, is 0 to 255. Now let's move on to the signed range. Okay, so n is again 8 bits for 16-bit computer for a char type. So if you have 8 bits, or if you are given 8 bits, if the memory gives you 8 bits to store your character value, then you can actually store a total of 256 values, but only one value out of the 256 values at a time. Okay, so if you are considering both positive and negative values, if you want to store both positive and negative values, then you have to divide this 256 exactly into 2 so that you give equal provision for the positive and negative values. So when you divide it by 2, you get a value 128. So 128 values for the positive and 128 values for the negative. So how will be the minimum and the maximum value calculated? Obviously the minimum value will be the last negative value that can be stored, and that is minus 128. You have an equation, and that is 2 raised to n minus 1 and appending a minus sign in front of it. 2 raised to 8 minus 1 and appending a minus sign, you get as 128. How about the maximum value? It will be 127, right? So, and that is 2 raised to 8 minus 1 minus 1. Okay, so that is the range for signed char for a 16-bit computer. It's minus 128 to 127. Now we'll see how the values of the int are calculated, or maybe how or what are the values. The size allocated or given for an int data type in a 16-bit computer is 16 bits. Okay, now for an unsigned int, if n is 16, then you can generate 2 raised to 16 values. Okay, the value of 2 raised to 16 is 65,536. The minimum value will be 0 and the maximum value will be 65,535. How will you get that value from the equation? It's 2 raised to 16 minus 1, 2 raised to n minus 1. Okay, so the range for unsigned int in a 16-bit computer is 0 to 65,535. Let's see for signed how it comes. For the signed int, if n value is 16, you get 2 raised to 16 as 65,536, and because you have to give equal provision for positive and negative numbers, you have to divide this by 2. So when you're dividing, you get 32,768. So 32,768 values for positive and 32,768 values for negative. So the minimum value will be minus 32,768, and that is 2 raised to 16 minus 1, and appending a negative sign to it. And the maximum value will be 32,767, and that is 2 raised to 16 minus 1 minus 1. I hope you got what I actually conveyed here. I mean the equation and the stuffs with regard to the equation. Now we'll move on to the int and char types for a 32-bit computer. I have not included the calculations in here because you get really very big numbers, and you'll get confused if I include the calculations. We'll just see the range. For the char type in a 32-bit computer, the size allocated is 8 bits. For 16-bit also it was 8 bits. So there is no change in the range. The same range you will get for a 32-bit computer. Coming to an int data type, there is a change. The size allocated is 32 bits. So when you calculate 2 raised to 32 minus 1, you get this value. I'm not going to read that value. See, for the signed int that considers both positive and negative values, you get the values that you can see on your screen right now. Again, I'm not going to read the value. It's really difficult to memorize all these values, but I think you can memorize the values of char and int of 16-bit computer. The value, the other for the other for memorizing int of 32-bit computer, you can actually memorize the equation like 2 raised to 32 minus 1, stuff like that. That would be much better. Okay, so next we'll see what are modifiers. What do you mean by modifier? What do you mean by the term, the word modifier? Something that is used to modify an item, right? So modifiers in C can be basically divided into two. One is sign modifier and the other is size modifier. Sign modifier is actually used to modify sign, whereas size modifiers are used to modify the size. Okay. Yes, sign modifier is of two types. You have already studied what signed and unsigned are if you have watched my previous videos. Yes, signed is used for storing both positive and negative values, and unsigned is used for storing only positive values. Okay, there will be no provision for storing negative values. Now what you have to understand is that okay, I'll come back to the sign modifier after mentioning what size modifiers are. They are basically of two types, and it is short and long. And a newly introduced size modifier is long. Okay, now coming back to sign modifier, what you have to understand is that both the modifiers, that is signed and unsigned, can be applied only to char and int data types. Okay, please note that point. It can be applied to only char and int data types. And in cases where you don't specify a modifier, the compiler will take it as signed. Okay, default value of a modifier is signed. Now we'll see what are size modifiers. in a very simple terms. See, you can see a table. As you look at the table, you might be confused by seeing all the values. I'll make it clear for you. Look at the second row. We have studied it about 16-bit and 32-bit machine. What is the size that is being allocated for the int data type? For a 16-bit machine, it is 16. For a 32-bit machine, it is 32, right? Yes, you have to understand that for a 16-bit machine also, the size allocated doesn't change. It's 32. Okay. Now see the first and the third row. The first row you can see that I have used short as a modifier, and in the third row I have used long as a modifier. What are the changes that you can observe from this table when you see a short in front of the int? Yes, for the 16-bit machine there is no change, but for the 32-bit machine you can see that the size allocated has been trimmed, or it has been reduced from 32 to 16 bits, right? And for the 16-bit machine also it is reduced. So it's actually doing what the keywords suggests. It's like shortening the size that is being allocated. Okay, there will be circumstances where you have to use size modifiers. We'll see it when we do programs. Now speaking about long int, you can see that the size of 16-bit machine has been increased, right, to 64 bits. Now you can see that the minimum value that is being allocated, that should be given for int is 16 bits. That's the reason why the short int for a 16-bit machine remains 16 itself. It's not going getting lower than the value 16. Okay, and the minimum value that has been allocated for a long int is 32, and that is why a 16-bit machine carries a 32 bits for long int. If you're getting confused, just leave it, because I don't think that this point is really necessary for you to do programs. Okay, now we'll see some of the points that is related to modifiers. Yes, you know that the size modifiers are short, long, and long, and each of these size modifiers can be used along with, yes, int data type. Short, long, and long. Three of them can be used with int data type. But with the double data type, you can only use the modifier long. And you know something? With the float data type, you cannot use any of the modifiers, neither the size nor the sign. Okay. Now, the void data type have neither size or nor sign modifiers. They cannot have any of the modifiers. And the minimum size of short int is 16 bits. Minimum size long int is 32 bits. That's what I explained in the previous slide. You will get to see 16 along with the short and 32 along with the long as minimum values for the 16-bit machine. The size of an int, a normal int, must be greater than or equal to the size of a short int, and the size of a long int must be greater than or equal to that of an int. I know that the last 4 points are confusing, that's why just leave it. When we do programs, right, we will come across all these points, then you will get to understand it better. Okay, now yeah, let's look into the float and double data types. For 16-bit and 32-bit computers, they are the same. Now here I'm not going to explain about how you get the range of values, because the range of values are really difficult to memorize. Just understand the range, and I will come back to this slide after taking floating point representation class, maybe in a late future. Just understand that you have decimal numbers when you can store decimal numbers when you use float data type, and the size allocated is 32, and the range starts from 1.17549 into 10 raised to minus 38 to 3.40282 into 10 raised to 38. Okay, here negative numbers can be represented, and that is why you get 10 raised to minus 38. See, Okay, I think I forgot to tell one point when I was explaining the sign modifiers in the previous slide. When you give a modifier as signed, or by default, when the compiler takes the modifier as signed, um, the compiler has to understand, right, whatever we input is a positive number or a negative number. How does the compiler understand? Now, this number, when it is converted to its corresponding binary, the conversion is actually based on the which encoding technique the system uses. Like, I've not taken encoding technique here with the class of data types, but actually there are three types: sign and magnitude, ones complement, and two's complement. So what is the encoding technique the system uses? Correspondingly, a value will be generated, and from the generated value, the first bit will be called as a sign bit, and that bit will be used to indicate the sign whether the number is positive or negative. If it is a positive number, that bit value will be 0, and if it is a negative value number, that bit value will be 1. Okay, so just for information I just told. Now, the next thing that you have to understand is when a float data type is being used, you know that a decimal number contains mantissa, exponent, sign, and all. So, different size are given or allowed for mantissa, exponent, sign, bit, and all. So, if I take that here in detail, we'll delay our programming classes again. So that is the reason why I have separated. I have considered personally to separate those topics from uh, my the class my class of data types in here. So I will be taking floating point representation, and then at that point I will be explaining everything related to floating point numbers clearly. Okay, so moving on to double. The size allocated is 64 bits, and the range is 2.22507 into 10 raised to minus 308 to 1.79769 into 10 raised to 308. Okay, so I hope you understood my class today. Um, okay then. So yeah, this is my last video on data types temporarily, because I will be, as I said in the start, I will be giving you extra information as and when required on data types. But then I hope that today's video was really useful for you. And yes, I know that to study, to by heart all these values, it's not that easy. There are some students who think, how am I gonna study all these things? For you guys, I will be coming with a surprise soon. It's a trick to study these data types. So I'm not giving much detail in here, but you'll see that in my next video. I'm not sure whether it will be useful for you or not. It's just a trial that I've done. So I hope that you'll support me for my next video that will be coming soon. So if you have anything to tell me, any comments, any suggestions, any requests, you can just leave a comment or give me a mail. Okay, I'll be giving you my mail ID here. So I hope to see your mails, and please like, share, and subscribe my channel. And you know something, the videos that I publish in my channel are really easy to understand. I really believe that my classes are easy to understand. So these videos will be really beneficial for school going students as well as those who are entering into colleges for computer science, and to those people who truly wish to study programming but has not got the chance to do so. So if you know people like that, I hope that you'll share my videos to them, so that I can be of some use to them. Okay, so thank you for watching, and God bless you. See you with the next video.